In right triangle ACE below, segment BD is parallel to segment AE, and segment BD is perpendicular to segment EC at point D. The length of segment AC is 20 feet, the length of segment BD is 3 feet, and the length of segment CD is 4 feet. What is the length in feet of segment AE? Use your eyeball ruler and try to eliminate unreasonable choices, and then from there use some mathematical knowledge to answer this on your own. Okay, so starting with the strategy that we've talked about quite a bit, that idea of an eyeball ruler, it's kind of hard for me on this particular one to see which of these answer choices is definitely unreasonable. So what I would do to make this a little bit more concrete for myself, I've made these pre-made segments that I've measured to be just as long as segment BD. And I've done this because I can't show you guys holding up a piece of paper and measuring the length of BD. So this is my way to show that strategy. So what I'm doing is taking congruent segments to that, and I'm lining them up on the unknown side length. So let's continue. So definitely more than 9. And as I drag this last one over, it's fitting almost perfectly. So when I talk about what I think the answer is going to be off the bat, I would say that the answer is probably going to be B12 because 4 of those little segment lengths that were 3 units long fit on segment AE. Now let's go through this mathematically and see if we get the same answer. One thing I do want to point out in this problem is there's a lot of words attached to the problem. But we didn't need to necessarily read the whole problem. A lot of what was given in the word problem is already marked on the diagram. The only thing that was not marked is the fact that these segments are parallel. And the reason that that does end up being helpful is because these are both right angles then. But if you look, again, it's already marked on the diagram. So reading all of that was probably pretty unnecessary. So what this problem is talking about is 2 similar triangles, and we have 3 ways to prove triangles are similar. We have angle-angle similarity, side-side-side similarity, and side-angle-side similarity. If I draw these 2 triangles separately, so right now they're overlapped, I'm going to draw them separately, and this is not drawn to scale. So this is the big triangle, triangle AEC, and here's the smaller triangle, triangle DCB. I see that they both have a right angle, and if you look in the diagram, they share this angle C, so angle C is going to be congruent to itself. So these triangles are similar by angle-angle similarity. All right, so let's mark what we already knew in these diagrams. We know that segment DC is 4, and segment BD is 3, and we know the hypotenuse of the larger triangle is 20. So what we really need to know in order to find the length of AE is we need to know what the scale factor is here. And we don't have enough information because we don't have corresponding sides. We know the hypotenuse on this side, but we don't know the hypotenuse on this side. If you notice, it is a right triangle, which allows us to use the Pythagorean theorem. So I'm going to do 3 squared plus 4 squared equals x squared. So when I do 3 squared, that's 9. 4 squared is 16. So 25 equals x squared. So that missing side length is 5. Now that I have corresponding sides, I can see that our scale factor is 4. 5 times 4 gives you 20. So over here on side length AE, this must be 3 times 4, which does give us that answer choice of 12 that we originally thought. You can see that by using the strategy on this one, it's actually a much shorter problem than when we go through it mathematically.